Sixth problem on Maxwell's equation. So in this video, I'm having three problems which are similar to each other. The problems are similar, but there is a little bit thought process to be applied while selecting the formula. Okay. So let us take the first problem. Mu is given, epsilon is given. So carefully observe here. This is not mu r or epsilon. It's complete mu and complete epsilon. Sigma 0, that means the medium is perfect dielectric insulator. Rho v 0. So these two conditions indicate that the medium is perfect insulator. We have to find some constant K so that each of the following pair of fields satisfies Maxwell's equation. That means two fields are given together. So here D and H are given. We have to find K. Where is K? Here is K. We have to find K. And in the second problem, E and H are given. Here also K is given. So in third problem also, same way, K is here with the T. The only thing is the epsilon and epsilon value changes in this problem. Otherwise, methodology remains same. So that's why both the problems are taken together. So now let us solve any one of the problems. So we'll keep this problem to the last. We shall begin with this solution. So mu epsilon value we can select later. First problem, D and H are given. Both of them satisfy Maxwell's equation. We have to find K. But there are four Maxwell's equations. Which one has to be selected? Carefully observe equation D. 6ax minus 2yay 2zaz. Look at this one. In D, there is no time variable at all. T is not there. In H also, this H also, there is no T. So that means the first pair of fields doesn't vary with time. They only vary with the distance. That's why we have to choose the Maxwell's equations which do not contain T variable. That means the first Maxwell's equation delta D equal to rho V. Look at this one. In this one, there is no time variable. And one more is there. Del dot B equal to 0. This also doesn't contain time variable. So we can choose any one of these two. But if you go to other two, they contain time variable. So here we have to choose any one of them. Which one to choose? Look at this one. K is present in H vector, not in D vector. So that's why we have to choose Maxwell's equation which contains H. That is here. So with the, we can convert B to H. Therefore, let us start with this del dot B equal to 0 and convert it to H. That is mu H is equal to 0. So we know that he is a constant. Del dot H is equal to 0. Right side is 0. So left side, either mu should be 0 or del dot H should be 0 or both should be 0. But mu cannot be 0. It's a constant given in the problem. So del dot H should be 0. Divergence of H is 0. So with this, we can find K value. So copy the vector H vector and keep it here for reference. Fine. Let us expand del dot H. So del dot H means dou Hx by dou x plus dou Hy by dou y plus dou Hz by dou z. There is a divergence, a scalar operation, no unit vectors. Careful. So we have to differentiate the components separately. Hx. This is Hx. Kx is the Hx value plus dou by dou y of Hy, y component, that is 10y, dou by dou z of minus 25z is equal to 0. Keep it in mind, dot product, no unit vectors. We have to differentiate component wise. Differentiation with x gives us k. This is 10. This is 25 equal to 0. So k is equal to 50. So that is the solution for the problem number 1. Let us look into problem number 2. Here, E contains time variable t. H also contains t. So E and H are time varying fields. So that's why we have to use the Maxwell's equation number 3 or number 4. Let us see what those equations are. So problem number 2. The Maxwell's equation derived from Faraday's law is containing time varying fields. And another one is one derived from Ampere's law. Curl H is equal to Jc plus dou d by dou t. So two equations are available. We have to choose the appropriate one from these two. How to choose? Carefully observe here. So look at this one. K is present in H and K is with T. K is with T. Suppose if I use this equation here, H is curled with del. Okay. So del is the vector operator containing partial derivatives of dou by dou x, dou by dou y, dou by dou z. So you are differentiating components of H with respect to x, y, z. That time the kt becomes 0. If you use H here, because of the differentiation with x, y, z, kt completely goes to 0. So k itself will disappear. So how can you find k? So that's why we cannot use this equation rule. So in this case, look at here b. B is differentiated with t. So b means h only. If you differentiate kt with t, we'll get k. So that means k will be present. So it is advised to use this equation. Okay. So let us go with this one. Curl E. As I said already, curl E means it's the determinant which can help you to solve the curl operation easily. Dou by dou x, dou by dou s, dou y and dou by dou z. Electric field E on left side, so Ex, Ey, Ez. On the right side, minus dou by dou t, B, but H is given. So what I suggest, convert B to H, mu H. So both E and H, both E and H are given. So we have to substitute for both sides, and both the fields satisfy Maxwell's equation. We have to find only the K value. Now look at E carefully. E is having only X component. So EX is there. So this EY goes to 0, EZ goes to 0. Only X is to be used. So now let us expand it. A cap X is multiplication of these terms, 0 minus 0 minus AY again. So the multiplication AY means these two vectors to be multiplied 0, then you have to multiply these two, minus dou by dou Z of EX plus AZ cap. What about AZ cap? Multiply these two, 0, then these two. So that is first term is 0 minus dou by dou y of EX is equal to, on the right side, mu is constant taken out, dou H by dou T. Now this is 0 completely. First term is minus AY. Let us check out. We have to differentiate EX with respect to Z, and here EX with respect to Y. EX with Z, EX with Y. So EX contains what? Look at this one. Here E contains Y. Let us take out this equation here. Look at this one. E contains Y component. So if you differentiate 20y, you'll get 20. So it works with Y. If you use differentiation with Z, no Z at all, it goes to 0. So what I suggest is completely goes to 0. So no need of these equations. So finally what happens? This is not required and this is not required. So only what is required is A cap Z of minus dou by dou y of EX. EX means 20y minus 2 into 10 power 6t. So this complete term, the coefficient of A cap X is EX, is equal to minus mu dou by dou t of H. Let us copy H from the problem. Here is H, complete vector, control C, place here itself, control V, that is H. Now let us go for differentiation with respect to Y. So differentiation with respect to Y means here it is 20. 20y differentiation is 20 minus this completely goes to 0. No y there is equal to minus mu differentiate with the t. Then differentiation of y is 0. Differentiate with t means minus k into a cap z. So both sides, the unit vector is a cap z. Cancel it. So here I'm having minus 20. Here minus into minus plus mu to k. So a is equal to minus 20 divided by mu. What is mu? It's given in the problem. Let us see. Yeah, look at this one. Mu is 10 power minus 5 Henries per meter. Henries per meter. So 10 power minus 5, the complete value of mu is given there. So minus 20 divided by 10 power minus 5 is now 20 into 10 power 5. That is the K value. So we solved both the problems. Both of them, a pair of fields was given and both of them are satisfying Maxwell's equations. So we substituted them into the Maxwell's equations and solved to find some constant K. Now there is one more problem which looks almost the same. Let us see what is the difference here. Control V. Okay. Here also same. E is given, H is given. It looks almost same. Only thing is K. Earlier it was with H in the previous problem. Now it is with E. So which Maxwell's equation to use? Let us copy both the Maxwell's equation. Minus dou B by dou T. Another one is curl H, conduction current, dou D by dou T. Look at where K is. K is with T in E. So E has to be differentiated with T only. E has to be differentiated. Here, if you substitute, what happens? Differentiation with XYZ will remove completely KT. So don't go for this. Go for this one. D means epsilon E. If you differentiate here KT, you will get K. That's why we have to use this. In the previous problem, we used this first equation. Now we have to use second equation. So the problems look alike. Equation is different. Equation is different. So let us go with del cross H. J means sigma E. D means epsilon E is the correct thing. Now look at this one, sigma 0. So that's why this term is not there. And this is epsilon. So curl means, we know the curl as usual. Curl can be solved using determinant method. Dou by dou y, dou by dou z. Next is hx, hy, hz. Which component of h is present? See z. Since z is present, 0, 0, h, hz component is equal to epsilon dou by dou t of electric field E, which is already given. See, look at it. It's a complete vector. It's going to be 20y minus kt ax cap. The vector is to be copied completely. Left side components, right side complete vector. Let us solve this one. Ax into dou by dou y of hz minus 0 minus a cap y into dou by dou x of h z minus 0 plus a cap z, both of them are 0, is equal to epsilon. Differentiate with the time, 20y, 0, minus kt, minus k, into a cap x. Now, we have to think of hz now. What hz contains, which component it is. So see here, guys, carefully. This one. Hz contains y here, y. So it can be differentiated with y. All others are 0. So HZ can be differentiated with Y. This is good. HZ differentiated with X goes to 0. There is no X at all. So A cap X. So we didn't copy that component. What is that one? Y plus 2 into 10 power 6t. Y plus 2 into 10 power 6t. So the differentiation is y plus 2 into 10 power 6t. The remaining all terms are 0. So minus epsilon k a cap x. So differentiate this one now with respect to y. So this is ax. Differentiation of this one is 1. There is no y this side 0. Minus epsilon k a cap x. A cap x cancelled. So 1 is equal to minus epsilon k. So k is equal to 1 by epsilon. What is epsilon value? Get back to problem. 4 into 10 power minus 9. Four into 10 power minus 9. That is equal to minus 0.25 1 by 4 into 10 power 9. That is the value of k. I guess we have understood how to choose appropriate Maxwell's equation to address this kind of problems. Thank you.